So I'm absolutely thrilled that my first book, which came out 2 years ago in French, is now out in English as well. It's called The Equation of Knowledge and it's been published by CRC Press, and you can of course find it on Amazon and other online websites. Now, having a favorite book is, I guess, kind of having like a first child. Even though you might have a favorite, it's not necessarily nice to say it out loud. But I'll be honest with you right here. This is the most fundamental book I've ever written, and probably the most fundamental book I will ever have written. Yes, because it arguably addresses the most important question of all. Think about it. What is the most important question there is? What is the most fundamental question of all questions? Is the Riemann hypothesis true? Or what is life, perhaps? Or are we alone in the universe? Or what are the fundamental laws of physics? Or does God exist? Well, I would argue that there is a much more important question than all of these questions combined. And this more important question is how to know. Yes, because if you can answer the fundamental question of how to know, then you can use the answer to this question to answer all the other questions. As computer scientist Ray Solomonoff, one of the iconic figures of the book, once said, "In science, my interest was more in how things were discovered than in the contents of the discoveries. The golden egg was not as exciting as the goose that laid it." And this book is not about the golden egg, it's about the golden goose that lays all of the golden eggs of science. It's about how to make sure that a given goose will be laying golden eggs, and it's about how to verify that a given egg is indeed golden. Arguably, this is the most important questions of all. Now, traditionally, we tend to associate this to epistemology and to the history of science, and in this book, you will indeed find a lot of discussions on the great philosophical ideas of Popper or Hume, and on how Einstein challenged Newton, how Gödel upset mathematics, and how Darwin revolutionized biology. But all of this, while interesting, is not the heart of the book. The heart of the book is a central claim that has long been controversial, but is becoming more and more consensual, at least within the philosophical community. And this claim is that the right way to know, the correct approach to thinking about the world, is to follow as carefully as possible the fundamental rules of probability, as Laplace argued over 2 centuries ago. This bold and fundamental claim is sometimes known as probabilistic thinking or Bayesianism. In particular, Bayesianism strongly relies on a fundamental theorem of probability theory known as Bayes' rule, because it was first introduced by English mathematician Thomas Bayes. Crucially, the book argues that Bayes' rule should not be thought as a mere mathematical curiosity. Instead, it is arguably the fundamental rule to follow to achieve inductive reasoning, which corresponds to inferring probable unobserved mechanisms out of observed data. Or, as Laplace would put it, Bayes' rule is the one way to compute the probability of causes given the known events. It is the way to move from observations to general reliable theories. This is why I called it the equation of knowledge. In the book, I list a large number of theorems and empirical evidence, from the Jaynes-Cox theorem to the Bayesian brain hypothesis, that strongly suggest that any deviation from the laws of probability inevitably leads to suboptimal, if not self-contradictory conclusions. The book thus defends the superiority of pure Bayesianism. However, unfortunately, these laws of probabilities are computationally intractable, meaning that they require unreasonable amount of computational power. Our computers and our brains simply can't be pure Bayesians. We must then resort to approximations. This is the starting point of what the book calls pragmatic Bayesianism, whose aim is to be as faithful as possible with respect to the laws of probability, despite finite computational resources. I then present the current state of the art in the science of pragmatic Bayesianism, which is one of the most exciting current research area, especially given the advent of machine learning and big data. And finally, I illustrate all of this with a huge number of examples, from lawsuits to medicine, finance, and cognitive biases. To really motivate you to check out the book, I would like to conclude this video by reading the conclusion of Laplace's 1814 philosophical essay on probabilities. He wrote, "If we consider the analytical methods that the theory of probabilities gave rise to, the truth of the principles it relies on, the subtle logic that demands its application to solving problems, the public utility good that is built upon it, and the extensions it has received and can still receive, given its application to the most important questions of natural philosophy and political economics. If we then observe that even in things that cannot be reduced to computation, probability theory allows the most reliable insights to guide us in our judgment, and that it teaches us to steer away from the illusions that often mislead us, we shall see that there is no science more worthy of our meditation and whose results are more useful. End of quote.